I had my mute on when I meant to have it off. Everybody's back. That's good. We'll just dial this down here. So I should be able to do this. You can see me testing testing the pen there. Okay. Do. Yay. Okay. So, and then this works too, right? Okay. Unfortunately, I can't just hit undo because Photoshop... I think my install of Photoshop just needs to be... I need to either reinstall it or just get Windows 10 or whatever. I'm still on Windows 7 because I'm cheap. And it works, so... Okay, so let me do this. So I have this saved to my desktop. Where did I put it? There it is. That's not super helpful in its current size. Okay, so... hopefully this will work. Crop. Copy. And I should be able to just paste this in here. Yeah, there we go. Okay. So it might be really hard for you to read that text on the side, but that's okay. I just need to be able to see it. There we go. That might be a little better. So these are the questions that you asked me earlier, so I'm happy to go over those. So we'll do this first one right here. Oops, that's not the pen tool. There we go. So I'm going to start here. So the speed of light is 3 times 10 to the 8 meters per second. How long does it take for a photon of light from a laser to reach a satellite 3,486 miles away? So this is my distance. And this is my speed. And my question is asking me how long, so I need to figure out how long in time it will take for my photon to go this distance. So what we're going to do is we're going to start with the number that we were given. So we were given miles. My speed relates a distance to a time, but it's only if it's in meters. So I need to get to meters somehow. So something like this would work. I can turn miles to kilometers and kilometers to meters. And if I know how many meters away the satellite is, then I know how many seconds away it is. So that would turn this into seconds. And then we'd be able to answer the question. Excuse me. Okay, so now we can look up these numbers. So how many miles and how many kilometers? So a mile is 1.609 kilometers. I have that memorized. A kilometer is 1,000 meters. And our speed is 3 times 10 to the 8 meters is 1 second. So let's do the dimensional analysis here. So we'll go 3486 miles. We're going to cancel out miles for kilometers. We're going to cancel out kilometers for meters. And then we'll cancel out meters for seconds. And I don't know why my throat is so dry now. There we go. I might have to just go get more water in a second here. All right, so all of these cancel out. And now I can fill in these numbers here. Gosh. 1 mile is 1.609 kilometers. 1 kilometer is 1,000 meters. And then I go 3 times 10 to the 8 meters in 1 second. So we'll punch that all into the calculator. You're going to get a very tiny number. I put a negative in my answer for some reason. There we go. So I got, when I did this, 0.018696. So we'll say 7 seconds. So your ping to this server, 3,486 miles away, straight up, would be 18.7 milliseconds, which is pretty good. I'm going to give you a second to look at this. I am just going to go get more water because I clearly need to drink more water. I'll be right back. All right, I'm back. Sorry about that. I have to actually drink the water that I got here. I gotta move the mic back. There we go. Remember, stay hydrated. All right, so next we'll do the zinc question. I'm gonna have to keep working in this workspace, so that means that I have to go like this, and then go deleted, like strong bad here. I didn't do this. There we go. All right. The density of zinc is 7.133 grams per cubic centimeter. 9.018 grams of zinc pebbles are added to a graduated cylinder that has 20.6 milliliters of water. Before the zinc, what will the volume of water plus zinc be in the graduated cylinder? Okay, so if I know the density of zinc, and I know the mass of zinc, I can turn mass into volume pretty easily, right? I just take mass of zinc, divide it by the density, and I get volume. So let's do that real quick and see what we can do with that. So I have this many grams of zinc, and then I'm going to divide it by, so grams of zinc per cubic centimeter, and that's just the density. And so what is that? Where's my calculator? 9.018. So I got 1.264 cubic centimeters. So that's the volume of zinc. Now, what does this information do for me? Well, if I have a graduated cylinder like this, and it's filled with water to some level, say 20.6 milliliters, that sounds like a good level to fill it to. If I were to add something to it, like say my zinc, boop, there's my zinc right here, then the water level will go up, won't it? Now, how will the water level change? Well, presumably this will add to this because the water can't share the same space as the zinc. So I would just add those two numbers together, but they're in different units, so that's kind of a problem. Until you remember, oh, these are the same unit, right? So I can just add these together. I'm just going to change one to the other, and then I'll just add them together. And then I'll do Sig Figs. So can't do this one because I have no number here, no number here. But this one's good. So I'm going to round to that spot. So the answer that's expected should be something along the lines of that. 21.9 milliliters should be the answer for that. Oh, that might be all the questions on my screen here. So now I can go to the one that's in the chat log here. So for Sig Figs, I could just scroll down now. So if you have a number like this number as written has 2 sig figs. This number is written as 4 sig figs. So your answer would have 2 sig figs. If you needed a third sig fig for, say, the top number, like you did the operation and your answer is supposed to have 3 sig figs, then what you'd have to do is you'd have to add the 0 in yourself. So you're allowed to write in a 0 if you need more sig figs than your calculator or your calculation provides. So if you do the problem and your calculator just reports 8 as your answer, but you actually are supposed to have 3 sig figs, you could write 8.00. Because you know to 3 sig figs, it's 8.00. That might be everything that was asked for me. Okay. Yeah, those are the 2 questions that I had in the chat, so I can just clear all of these now. Boop, there we go. All right. Yeah, any other questions, let me know. Yeah, so if you have a number that has something like this in it, and this could be any number you want to, then because of this decimal rule, these zeros are sig figs. Now, if your number is this, then these zeros end up becoming placeholders. So be mindful of which situation you're in. If you have trailing zeros like this, like so 500 is written like this is just one sig fig. But as soon as I start doing something like this, now all the sig figs, now they're all sig figs. And it's because of the decimal rule. Remember that in a decimal, anything to the right of a sig fig is a sig fig, and anything to the left is a placeholder. It doesn't matter where the decimal occurs or where your sig figs occur. They can be wherever you want them to be. As long as you have that decimal, the rule applies. Is that 10 to the 8? I'm going to assume that this is the number that you meant. I realize that it doesn't really convert super well in text. So if I want to do this conversion, remember that you can convert any prefixed unit to the base unit. And so 1 micrometer off of your metric chart is that. And so that should be your answer. Yeah, if you're copying and pasting from the textbook, that totally will just happen. So I just want to make sure that that's actually what it is, though. So for that one, you do more or less the same thing. Just set up your unit so that you can turn kilograms into grams. And then what's the relationship? Well, a kilogram is 1,000 grams. And so there you go. So when you multiply, you add the exponents together. So that's why I'm doing this so quickly. Because 10 to the minus 2 is... Oh, okay. Yeah, there you go. Yeah. So let's see here. So if I'm traveling 19.1 miles... Oops, I lost my decimal point there. And I'm going 101 feet per second. How long will it take to travel that distance? Okay, so if I'm starting with miles here, and I'm given... Let me just write both of these things out. So 101 feet per second. So in order to get from a distance to a time, I'm going to have to use this relationship, right? But that would mean that I need to turn miles into feet. So let's do that. Miles turn into feet. And then once I know how many feet I have, I know how many seconds it takes to do that. And so that'll be the units of my answer. So we're going to go 19.1 miles. And we're going to go, that's some number of feet. And once I know how many feet I'm going, I know how many seconds that takes. And so the relationships here are, there's this many feet per mile. And we're going 101 feet every second. So we'll write those numbers in here. And there you go. So that'll tell us the number of seconds it takes us to do this distance. I mean, provided I type it in the calculator correctly. So 998.4 seconds, or 998. And if I want that in minutes, that's not many minutes. All right, so it is at the top of the hour. So what we're going to do is I'm going to put the break timer up. But during the break, please put more questions if you have any. And go drink more water so you don't end up like me. I don't have a timer out. Let me get that real quick. Okay, cool. So we'll just do this. And I'll hit play on the music again. And I'll see you in about 10 minutes. Alright, we're back. Let me wind this down here. I need to get to this screen. There we go. Let me clear all that away. Where was the question that you asked? There it is. So, sometimes you get weird conversions. Kilogram meters per second squared. And we want to turn those into something in these. Where is it? There it is. Pounds, miles per minute squared. Those are weird units, right? But it's just for practice. And there might be reasons that you want to do this. I was talking about a case where I had to use non-standard units in grad school because I was working with really tiny quantities, and doing the conversion from liters to milliliters and atmospheres to torr 60 million times for every experiment I did was just tedious. So I just wrote a new constant. Or actually, more appropriately, the graduate student I was working with wrote a new constant, and then when I took over his work, I started writing that or using that constant too. All right, so in order to do this, I got to get rid of these old units and make the new ones. So if I want to turn kilograms into miles, then I'm going to have to cancel this out and put miles here, right? So I can do that. That's easy enough. Not kilograms. Oh, goodness. Sorry, I'm the worst. Let me try that again. I circled the wrong thing and then got confused. You can't convert kilograms to miles. Don't do that. So I want to do pounds, miles. So kilograms to pounds. That's what I meant to do. All right. So we'll turn kilograms, which cancels, into pounds. There we go. So we'll do that conversion, and we'll get the number later. Then the next one we'll do, I'm going to get rid of meters and turn it into miles here. So we'll go meters, miles. And we can look up these conversions later. And then the last one I need to get rid of is I got to get seconds here to be minutes, but I need it to be squared. So I'm going to put, first I'm going to do this so that these cancel out. But that only cancels out one of them, right? I need to cancel out a squared one, so I actually need to do something like this. And now I will cancel out seconds squared and get minutes squared as a result. So now when I do all of this calculation here, I should have pounds times miles divided by minutes squared, which is what's shown on the screen. So now I can go and look up the conversion. So a kilogram is 2.204 pounds. There are 1,609 meters in a mile because it's just a kilometer, right? Or a mile is just 1.609 kilometers. And then in 1 minute there are 60 seconds. But in 1 minute squared there are 60 squared seconds. So when I square the unit, I also have to square the number. And so now I can just punch all this in the calculator, and the units that are left over will be the units of my answer. I don't know why I keep thinking that. There we go. So I'll punch it in the calculator. What do we get? 1,800. 2.204. 60 squared. 1,609. And I should have two Sig Figs, which would be 8,900 of this unit. There you go. All right, so the next problem that was there was, looked like this one, 55 cubic centimeters to inches cubed. Same sort of process. So if I want to get inches cubed out, I would need to turn centimeters into inches. But that would only cancel one of the centimeters. I need to cancel a cubed centimeter. So we'll cube the whole thing. And then we'll write the one-dimensional unit. One inch is 2.540 sig figs, or 2.540 centimeters here. And then remember, my cubed goes in to all these things. So I would be doing 55 divided by 2.540 cubed. And the answer I get is 3.4 cubic inches. Yeah, this number over here had 2 sig figs. So my answer also only has 2 sig figs. Same thing here. For the next question about color, so this does require you to do a little bit of color theory. So you'll have to know that, like, if I mix two colors together. So for example, if I had a solution that was red, and then I mixed it with a solution that was, say, blue, then you should expect a result through normal mixing to be something like this, right? Because red and blue added together make purple, right? So these colors would mix normally. So this would just be a mixing process. Red plus blue is purple. Kind of like how if you have yellow and blue, you'd get green, right? So there are normal color mixing patterns that occur, and these would be physical processes. However, if you did something like this, where you had a red liquid, and then you mixed it with a blue liquid, and the result that you got was, like, say, orange. That doesn't normally happen, right? Red plus blue doesn't make orange. Red plus blue should make purple. So instead of mixing two colors together and just getting the sum of those colors, you've mixed those two things together and gotten something totally different that is orange. And so this would be chemical. So if you mix two colors and you don't get the result you expect, a chemical change must have occurred because you consumed the original products and created a new product with a different property. For that question that you just asked there, 60 seconds equals 1 minute is an exact number because we've defined it. There's exactly 60 seconds per minute, so that's infinite. So that conversion would not affect your sig figs. So remember that definitions don't affect sig figs because they have infinite sig figs. With the color thing here too, there's another example that I like to do, which is if you mix two things together. So if you mix red plus clear, or not clear, but colorless, you would normally expect that a red liquid and a colorless liquid would make a red liquid, but let's suppose that you got a colorless liquid instead. That's not normal, right? Something red mixed with something colorless should just be red. Maybe a little fainter red, but it shouldn't just disappear. So what must have happened is that this must have reacted, and you made something new. that had this color. So that's the question that you can ask is, if I mix these two things, so if this is a mixture of red and blue, then they did not react. But if these reacted, and this is new, then you must have done chemistry. So you'll have to apply your knowledge of colors. And I'm going to stick to the common colors. So like red and blue make purple, yellow and blue make green, red and yellow make orange, that sort of thing. Other questions, let me know. So the difference between chemical and physical changes is that if the formula of the substance changes, then you've done a chemical change. That's difficult to apply. So like looking at the chemical formula of something isn't something you can always do. So what you have to do is you have to look for a substance that has vastly different properties than the original, or turning it back into the original thing is very, very difficult. So for example, if you set paper on fire, it's very hard to undo burning something. Like you'd have to plant the ashes, grow a tree, cut the tree down, process it into lumber, and then into paper. That's difficult. So burning something causes it to change pretty much irreversibly. A physical change you can undo trivially. So like if you freeze something, you've turned it from the liquid state to the solid state. So look for ease of reversibility. Can you undo the action that is being proposed? Or is the action just not doing anything at all? So like if I look at something and say, oh, it's blue, me looking at it doesn't change the object in any way. So color that something has would be a physical property because you don't change its chemical identity. Anything that seems like, oh, these things reacted, that's chemistry. So that'll be a chemical change. And then remember to look for things in chemical changes and physical changes. So words that help you pick one or the other. Any phase change is physical. Any reaction is chemical. So words like burning or makes a gas or decomposes or fizzes, those are all examples of chemical reactions. Things like changing its shape, stretching it, bopping it, twisting it, turning it, that sort of stuff. Those are all physical changes because you still have the thing you started with. Well, let's not get into that. Let's not get into photons or quantum mechanics. You change its behavior, but it's still a photon. All right, what else we got? Let me know. Drop anything in the comments that you need, or chat, actually. Don't go down to the comments because they're disabled. So the exam is units 1 through 8. The only math that's on the exam is units 2, 3, and 4, really. There might be temperature stuff, too, so you might have to, like, convert a temperature. I forget what's on there. I wrote it a while ago. But there are a lot of questions from units 5 through 8 that don't require any calculations at all. So, I want to say it's like 50-50. Pinching my leg, sitting on my chair here. The difference between scientific law, fact, and theory. So, a law and a theory are both ways of interpreting facts. So, a fact is something that is reproducible. Like, no matter how many different times you do the experiment, you always get the same result. That would be a scientific fact. And then we use facts in different ways so we can get laws and theories out of them. So a law is sort of a summary of how your facts behave. And we would simplify that by saying this is how matter behaves. But a scientific law does not explain why. So an example of a scientific law would be objects fall down when dropped. Now it doesn't tell you why, it just says that they do. A theory, on the other hand, explains why facts are observed. And so a theory is a much more in-depth and in detail sort of thing. So a theory could tell you why do objects fall down? And it would explain, like, hey, objects are attracted to each other if they have mass. But why are they attracted to each other? You'd have to go to, like, a discussion of gravitons and stuff like that, which I don't think that discussion exists yet. So gravity's not a great way to propose the theory topic, but there are many other theories out there that can be explained. So, like, the theory of evolution. Why do things evolve traits over time that are beneficial to their environments? And so the law that you would observe for maybe like a selection of birds would be that birds with longer beaks proliferate on this one habitation. But then, for theory, the reason that happened would be, oh, well, nature doesn't program itself to get long-beaked birds. It's just picking randomly, and the birds that have short beaks can't get enough food and then don't survive. But the birds with long beaks can survive and then can reproduce. And so you end up with only long-beaked birds in this particular habitat. So that would be the theory behind it. More on the difference between fact and law. So a fact is just one observation. A law is a bunch of these put together to try and describe matter. So if iron rusts when exposed to oxygen would be a fact, so would silver corrodes when exposed to oxygen, or cobalt corrodes when exposed to oxygen, or copper corrodes. Those are all facts. But you would put them together and the law would be metals corrode when exposed to oxygen. So a law is just sort of a general collection of facts that are similar enough that we can say, oh, this is the law. This is how the matter behaves. So exact numbers are counted or defined. Inexact is everything else. Everything else is inexact, besides what we've defined as exact. So if you define a meter to be 100 centimeters, those are exact. Anything you measure against that meter would then be inexact. All right, any more questions? We're going to do last call for questions here. All right, I guess if we're all done with questions, you can always email me anything if you have it. Like, email me tonight, jump in the Discord, send me questions through direct message, or post them in the channel. Please use the Discord. I know a lot of people are using it and getting a lot out of it. And yeah, let me know if there's anything else that you need. I unlocked the quiz for Unit 7 and 8. It is set so that if you do it at the end, it will show you your answers. So you can use that to study. But quiz number, whatever number it is, the Unit 7 and 8 quiz will not be due until next week. What did I just do? I just broke my program here. There we go. Oh, my computer is being stupid. Hold on. There we go. Okay. So yeah, send me any emails that you have. Let me know if there's any other questions. Good luck on the exam. Don't panic. You're going to do all right.